Hi, and welcome everyone to the Reimagined Mobility Podcast series. I'm here with Chris O'Connor from Humanetics. Chris, thanks for joining us as we talk here about reimagining mobility. I mean, the stuff you guys are doing is a perfect area that very few people talk about and maybe oftentimes is in the background, but nonetheless, super important. So Chris, give us a little bit of a background. Who are you? What is the company you're currently leading? What are you guys are doing? And then let's jump in together and talk about how do we reimagine mobility as we go forward here together.
Yeah, certainly. Thanks, Stefan. It's great to be here on your podcast, and congratulations on your recent victories on basketball. It's actually, Humanetics may not be known by everyone, but certainly everybody knows what a crash test dummy is. It's an iconic, very noticeable, whether you're 3 years old or 83 years old, you know what a crash test dummy is. And it's really iconic around safety, and it's iconic around Humanetics and what we're all about. You know, my background, I'm an engineer. I'm the president and CEO of Humanetics, and it really drives our passion at Humanetics around saving lives and making a difference. So this is something we're super excited about. It doesn't always get enough attention, and unfortunately, safety in itself doesn't get enough attention. If we take a look at fatality rates and injuries that are occurred around the world and in the U.S., it should be absolutely unacceptable. And yet we continue to live with this type of, fatality rate as if it's expected, and there's more we can do.
Excellent. So you talked about it, the crash test dummies, right? I mean, everybody has seen it to one degree or another, either in movies or in advertising or wherever, different OEMs using it to a different degree in advertising. But again, certainly movies or other stuff. But Chris, give me a little bit of an idea. Probably the crash test dummies I have in my mind, or if I were to ask my kids, probably comes from a movie or something we've seen a long time ago. I don't deal with them on a regular basis by any means. How have they changed over the last 5 years or last 10 years? And then share a little bit, how are they going to change over the next 10 years as we talk about reimagining mobility here?
Well, great question. So Humanetics has a long history. 1952 was the first crash test dummy, and it wasn't even used in an automobile application. It was used for ejection seats with the Air Force, and we were protecting pilots. And so the first use was that, very much more size and a bit of mass. And over time, it developed. And really the exciting and interesting part of the history is it was really Sam Alderson who started the first crash test dummy in 1952, Alderson Research Lab, which became Humanetics in the future. And so we have a rich history, but he was working with Colonel Staff in the Air Force, and Colonel Staff eventually said, hey, listen, we're losing more people in cars as these super pilots are driving to their aircraft in their sports cars. We're losing more there than we're losing in the aircraft. We have to do something about protecting people in the vehicle. And really that brought us into the 60s and then into the 70s. And there is numerous early versions of the crash test dummy that were developed. Again, more still without any sensors, more on size and weight and looking at it to see what happens. So it's, the very early simulation, if you will. It's the early look at what happens physically. Of course, crashes are recorded today still because that's very important. But the difference from then versus today, when you went into the early 80s, you developed probably the most iconic crash test dummy that exists today. And that 1980s was the Hybrid 3 family. And that had a few sensors, in most cases from 0 to 10, outfitted heavily, might have 15, 20, maybe 30 sensors. That's it. So fast forward to today, our most advanced crash test dummies, which are anatomically much more correct, biofidelically matches what happens in the real world. And science has changed to the point where now we can have 150 sensors. And so we have much more information. We know whether you bruise something, tore a ligament versus broke a bone. So the accuracy is incredibly more advanced. And as we solve one problem, we find new ones. This isn't any different than any other advancement in technology. So the first crash test dummy is really just trying to save somebody from going through a windshield. That was the biggest source of death. We protected that, and we saw paraplegics and others being formed in crashes. So now with the seatbelt, and everything is based on the crash test dummy, the seatbelt has advanced, of course, the 3-point, but also with retracting and other safety protocols, the airbags and multiple airbags for different reasons, pretensioners and other safety devices that are added, obviously are all helping to maintain that occupant in a safe environment to make sure that they're safe moving forward. And so we've advanced a lot, but now we're identifying other areas. There's vulnerable occupants that aren't considered as safe today as others. And so these are areas that we're peeling the onion back looking at.
Very interesting. So pretty much almost every podcast we do as we reimagine mobility here with our guests, simulation digital twins comes in one way or the other in 9 out of 10, okay? So what you just mentioned, again, we had 30 or 15 sensors. Today we have 100 plus sensor on these things. And as you mentioned also, we now have seatbelts with pretensioners. We have different airbags. It's not just coming out of from the front anymore, a side, in back, to probably top, all sorts of things that I'm not familiar with either. But I can envision that having a digital twin of a crash test dummy or of a driver that can then be used in simulation to see, okay, with this sensor, with this technology that an OEM can decide not to integrate, we have the chances of moving people from having broken bones to maybe have a bruise by X%. Is this crazy thinking? Is this where the industry's going? Or are we already there? Or talk a little bit about, again, the digital twin aspect of what you guys are doing.
Yeah, Stefan, we're actually right in the middle of that right now. And I'm always going to say we're not moving fast enough. There's more we have to do. And why is that important? When you have 1.3 million people that are fatalities around the globe, and 42,975 in the U.S. was the last recorded number, or some estimate it could be 43,000. That's significant. This is like a 747-400 crashing every week. And if one crashed, what would happen? We would stop every airline traffic that happens, and yet we're tolerating it on our roads, and we're not doing as much as we can. So cars are getting safer, don't get me wrong. With the advent of a testing mechanism like the crash test dummy, we're now able to test, and it more replicates what we're seeing in true crashes. And so the crash test dummy is developed with cadaver testing, with real injury that comes back through hospitals and through surgical tables and feedback. And so these are the basis for how a crash test dummy is developed. And with that, then we're able to create simulations for that. And that's very important because we can't do every crash scenario. Maybe in a few minutes, we'll talk about active safety versus passive safety. And that's a topic where it's near and dear in our heart as well. But the reality is there's too many scenarios that you could possibly physically test. And I'm sure you've talked about this on many other of your podcasts. But the reality is, so we have to find the right simulation that makes sense. So the first level of simulation is a finite element model that's a direct correlation to the crash test dummy. And Humanetics provides those. And based on the material properties and understanding the injuries, we can create an exact simulated finite element model. And that's being used today by every OEM, every tier 1 supplier, every child seat supplier. They're using it. And remember, a crash test dummy is not just one dummy that's used in all applications. You have crash test dummies for frontal crash. You have crash test dummies for side impact crash. You have them for rear impact crashes. You have them in different sizes. A 50th percentile in the center of the corridor for a male from 1980. We'll talk more about that. And then you have a 5th percentile, which is on the smaller side, and a 95th percentile. And some of those are regulated, some are not regulated, some are used every day, some are not. And then you have child dummies. And there's child dummies that are used in the U.S. There's different ones that are used in Europe. It's not necessarily a common standard around the world. And so the finite element becomes the next level of simulation. And you've heard a lot about human body models. Of course, human body models have been in development for 20, 25 years. They're really looking at safety, but looking at it in a different way. It's much more of an R&D tool, whereas a dummy and the finite element models is more of a production tool for how do you make sure that that not only is designed to meet it, but then validate it after it's made to make sure, which you couldn't do with a human body model, the way that's prepared and set up. And then we also have ergonomic software. So Humanetics has the largest database of human body sizes in the world. These are direct correlations to people. And so these are really important in the early design of any product, including the vehicle. And this is used to make sure your field of vision and sight is aligned, your hand sizes, arms, torso, leg sizes in different regions. Obviously, an Asian population versus a Nordic population is going to have different variables there. And obviously, your car seat tracks, the size of your car, seatbelt, airbags, other things need to be rated for those areas. So we provide that software as well. And these simulation packages come together with the solver packages, which are provided by other companies as well, so that the car companies, OEMs, can actually design their cars in a package. Our crash test dummies and our ergonomics and other software play in that like an application, and they're able to run those as well.
Wow. Way more complicated or way more elaborate and detailed and extensive than I ever thought, for sure. So quickly, before we go a little bit to what you said, talking about active safety or also passive safety outside of the things you guys are doing on the testing side, you already alluded to it a little bit, different populations, smaller people, taller people, thinner, heavier, more muscular, less muscular, all of these things. I think that all makes sense. But to me, the question is, do you also look at if I wear a ski jacket because it's once again negative 20 degrees here, or I just have a t-shirt on or don't even have a shirt on? Does that play into? Does it play into what type of shoes I'm wearing? Do I literally go to the extreme of, do I wear a belt in my pants or not? Are these things that play into this as well, or am I taking it out way too far?
Well, hopefully we'll get way too far someday. So you have to take, as engineers, we have to solve problems and we have to focus on the biggest problems first. And if you look at the crash test dummy, it was designed around a male. It was focused on a male size, again, from the late 1970s and early 80s. That in itself has changed. So regardless of our clothing and our foot size, we have changed as a population. And we see people are bigger, they're taller. Look at our kids, in most cases, bigger than parents. If you look at third generation, much bigger than grandparents and great-grandparents, right? So the size and shape of people is changing. Better food, better medicine, better capabilities that allow for, us to change in size. So we can't have a set standard that doesn't change as well, because we have to be able to adapt the safety of our vehicle as the population changes as well. So when you look at the big vulnerable capabilities, as I've mentioned, it's designed around a male. So what we're seeing is females are injured at a higher rate. So you're 73% more likely to be injured, almost 20% more likely to die as a woman versus a man in the exact same crash belted. So I'm not talking about unbelted or any weird scenarios. In the same scenario, you're more likely to die and much more likely to be injured as a female. If you have larger size, if you have a BMI of 30 or more, which isn't that big because now that BMI of 20 from 1970s and 80s was the norm. Well, now a BMI of 25 is actually quite normal. And so it's considered obese from 1980, but if you look at the current standards, it's not considered obese anymore. It's the normal size. Well, at a BMI of 30, you're 80% more likely to die in a crash than somebody with a BMI of 20. And there's also similar statistics on elderly. We never envisioned that people would be driving at 70s, 80s, 90s. My dad is in his 90s. And it's a different scenario. It's not just that you're more frail and you're older and you're maybe not as quick, but the reality is your body shape changes. And so as your rib cage and other things move, gravity takes advantage of us. It actually opens up and you're more susceptible to organs and other injuries we wouldn't see on a younger person. So as you think about all these things, we have to address the vulnerable occupants. We have to say, what's different about a woman versus a man? It's not just size. They're not just smaller. They don't just sit closer to a steering wheel. Those things are true. But they also have a different pelvis. Their pelvis does not hold the seatbelt the same way as a male because everything was designed around a male. So we have to address the gender inequality that exists out there. And we have to look at how to fix that. And we have to look at larger sized people, which is more the norm. We have to look at elderly people. And so we have to address those with different tools. And some of those we'll do with crash test dummies and tools that we can do. Some of those we have to look at the simulation. To go back to your question, is we can do more with simulation to look at different sizes and shapes. But at the end, we have to have traceability back to a physical test. And the reason is, and as you well know, Dieselgate and other challenges we've seen, it's easy to design something to work. And I could design all the software and simulation to work, and I can tell everybody it works, and I can prove by simulation it works. But the reality is, things change between your R&D work and production. What happens in production? You have somebody else building in a factory. You don't know the material specifications. You don't know the welds, the joints, the workmanship. We have, plugs coming out of airplanes. Why? Workmanship, right? If those aren't tested in the physical environment, I don't care all the simulation in the world that you have, which, by the way, we're great supporters of and we're fans of. But at the end of the day, you can't only use simulation to ensure that you meet the levels of quality and requirements to put a 5-star stamp on a car.
Right. Very super interesting, Chris. And you're alluding a little bit. I think a few episodes ago we had a discussion about where I challenged, some of the industry big OEMs claiming we're going to get to 100% digital testing and validation. I guess 100% where, how to define this, that's the big question. But clearly you just mentioned in your space, yes, simulation will advance and will allow us to do more and be better. But the physical actual testing as we do today, as we did 20 years ago, one way or the other still has to take place. Very interesting.
And that's what brings us back exactly to your question of this digital twin. Because at the end of the day, we're not trying to replace one with another. One's not better, one's not worse. It's the combination of the two and working together so that you're doing less simulation and less physical tests, but you're specifying in areas that have better impact. And so you can make better results with more limited testing because you're going to have a more variety of testing, right? Because as you add in new variables, right, different sized people, different shapes, maybe to your point, whether you have a jacket on or a bigger shoe size, you can do that, but you have to then tie it into how do you validate that through the process. And so as more tests go up, and if we want to get to zero fatalities, this concept of vision zero that we hear from every OEM in the world, that we're going to do that, unfortunately, our active safety, our ADAS systems that we've brought into the marketplace, which I think are fantastic, I had been suggesting for the last 10 to 12 years that they're going to actually create more accidents initially, not less accidents. And if you look in the U.S. alone, our fatality rate's gone up by 30% in the last 10 years. So we have the safest cars we've ever had. We have more ADAS systems in the market than we've ever had, and yet the fatality rates are going up. And so what is that? We can't blame that all on the phone and distraction. And for 3 years, we blamed it on COVID. The government did. And it's like, listen, the COVID existed in the rest of the world, but we didn't see the same rise in injury and fatality rate that we did in the U.S. against other countries. So, clearly the lack of doing things is also a reason for our fatality rates going up. And so you have to keep raising the bar. If you don't raise the bar to the next level, you're not going to get to zero. And you can't wish it all away with saying we're all going to have autonomous cars in 5 years. We know that's not going to happen. I was originally told that in 2020, everything would be autonomous. And I was down in Washington, D.C. in Congress saying this will never happen. And yet it was forwarded by every optimistic car company who said we'll have it. And the reality is it takes a lot longer. It's more complex. We see snow on the road. We see weather conditions. We see dirt roads. We see a lot of scenarios where these systems are not working effectively today. In fact, they in themselves may be causing some of the distractions that we're seeing today. It's not just the phone. People are hearing beeps, they're hearing warnings. It's trying to steer them back into a lane. They're fighting the car. There's a lot of things that people are unfamiliar with, and the systems are still learning themselves that also could be causing, challenges that we're seeing on the road. And we have to get through it. I'm not saying let's stop. I'm just saying that we cannot forget passive safety, because at the end, what is it called? An accident. Accidents happen. Even when it's nobody's fault, you have cars that might be more automated than others. You're going to have people at different ages, with different visions, different sizes, different distractions. I always say, this distraction is not new that we have a cell phone. When I was growing up, My parents had 5 kids in the back of the car, and we were a pretty big distraction, I would say. And my dad reaching around to probably smack us in the head was probably another distraction. I'm not really sure, but the reality is there's always been distractions. You could say fast food is a distraction, right? People are eating and drinking and shaving and putting on makeup. There's a lot of reasons why people are distracted. The point is, the more comfortable they get with an ADAS system, the more distracted they're going to be. Because then they feel comfortable. They're driving down the road. They're on Super Cruise. They're using their Tesla. They can say, you know what? I can look at my phone. I've got this system here. And so what happens, it actually creates distractions. And at the end, we're still going to have accidents. So we have to figure out how to protect people all the time.
Right. Well, I think that the point you're making is ADAS systems and even autonomous as we move towards, I agree with you. We thought by 2020, we all have one, right? And we still don't. It gives us a false sense of security. And what we do then is, we let our guards down and we think we're safe in the vehicle. And we're not there yet. Maybe in 10, 20 years, but I agree with you. You're not there yet. So, Chris, let's maybe take it a step further again as we reimagine mobility here. Share a little bit, how much are you from, as I always envision, and maybe many of our listeners would envision, you're sort of at the end. The vehicle is developed. Hey, you know what? Now we need to test it because now we need a 5-star rating and we need some other things. We need to check a few boxes, not in a malicious way, but sort of, right? Testing always comes at the end, and with everything that we do, we always get squeezed. So, make testing faster. It's good. We need to get it out, launch starting, blah, blah, blah. How much are you guys actually working in the early development of vehicles, right? With your data, with your input, or your digital twin, as you mentioned before. But how much is Humanetics, or the crash test dummy space, truly actually involved in early vehicle development, specifically as it relates to active and all sorts of other safety features, passive as well, obviously, that we have in vehicles today and going to go see going forward in the future?
Well, great question. And again, not moving fast enough. But if you go back in history, you described the process, but it's not that way today. As I mentioned, the finite element model simulation software, we have a human body model aspect as well for our products. We have those ergonomic. So actually now, the design happens from the very first moment. Everything that's designed in a vehicle should have a safety element associated with it. And it didn't exist that way. In fact, even the ergonomics is just coming into the point of thinking about that. So we have the largest ergonomic software platform and for vehicle simulating, and we have now added the ability of safety into that feature as well. So when you're designing it, what typically would happen is you would lay out your ergonomics package, and then it would move down the line, and mostly OEMs, it's a whole different group. Then another group would be working on the safety, and they'd say, nope, doesn't work. Headliner's in the wrong place, steering wheel can't do there. Yeah, they can see out the window, but everything else is wrong and you have to change it. So now we're actually creating software queues. Now that we have all those pieces, we're actually tying in the finite element model into the ergonomics. So it'll give you clues to say, no, this will be a problem when you go to safety. This will be an area. So what we found working with some OEMs is it's taking weeks and months out of their development process, so you're not going back and forth. And this is really critical to make sure you're doing it early in the process. And then even the finite element modeling and the testing is really brought up much earlier in the process. So every subsystem is tested. It's not just a car crash at the end. You have sled testing, you're testing your airbags, you're testing your seat belts, your seats, your headliners, your interior cockpits, you're doing bodies in white, you're doing all those elements along the way, and you're simulating those at the same time. Not only with different body sizes and people, but then against what the standards are for which you will be measured, right? Because we need to change the measurement platform if we're going to really raise the bar, because, at the end, as engineers, you're going to bias. Even if your simulation said, okay, this works perfect for a woman plus a man plus an elderly person, if your test is only a 50th percentile, mid-sized male, well, at the end, that's the one that's going to pass, right? Because that's the one that gives you the 5-star, rating. Yeah. Now, you have different ratings there. You have pedestrian, you have active safety and passive safety all playing it. So they all wrap in together. But at the end of the day, you're always going to compromise your testing standard requirement against, all the others. So you can do all the, extra simulation in the world you want to, but at the end, you're gonna lean towards what is required to pass the test. Just like all of us do when we're in school or anything else. Tell me what's going to be on the test, because that's
enterprise behavior. Right? Chris, it's been super interesting, and I think we could probably go on another half hour or an hour here, because this has been very informative, very educational for me, and certainly your statistics are, I would say, eye-opening and sometimes also concerning, right, that we're not doing better yet. So very super interesting.
Absolutely right. Thanks for having me on. It's a pleasure. We're overly passionate, so that may come out, because at the end, we all can do different jobs and have different charters, but we have passion around saving lives and how to make a difference, and so we feel it's not just a mission, it's an obligation to make a difference. And if we can save lives and we can take 42,795 down to 40,000, down to 30,000, that's what's important to us, and that's what gives us purpose every day.
Amen. Yeah, amen. So maybe then last question for you, Chris, totally off the cuff, is what is the next car you're going to buy and why?
I get many people asking me what's the safest car to drive. And the first question I have to ask them is, tell me what accident you're going to get into. Because, whether it's a frontal crash or a side crash or a rollover crash or a rear impact crash, but the only thing I can say is, and the Insurance Institute has provided statistics, is if you're in a micro car, you're 3 times more likely to die if you're being hit against a large car, 2 times more likely if it's a small, medium car versus a large car. So at the end of the day, mass is still important. And I'm greatly concerned about electrification relative to adding mass, because now you put another ton or a ton and a half or 2 tons on a car. It's not just our guardrails and roads are not, adjusted to that. It's the disparity between, a Hummer that weighs, 5 tons and, another car that is your family car that's going to have 5 people in it, and you're going to run it over and think you just hit a speed bump or something. So, your safest car is still going to be one with a larger, more mass. We made all our kids, when they were 16, drive the newest, largest car we had, because the newer cars do have more features in them. We still want to see them advance faster, but the larger car also gives you the added mass protection. So you can't beat physics at the end of the day.
Yeah, very, especially here in this country. I want to go to Europe, where cars are generally much smaller in the same size, but here you have anything from, let's say, the size of a Fiat 500 to the Cadillac Escalade, or the Hummer, as you just mentioned, which is not only big but also very heavy.
And we have a significant bumper variation. So you have compatibility in Europe. I wish we had that in the U.S., but even a small amount, if you took a crash of 2 cars together, the identical cars, and one had 2 pounds less in air pressure in the tires, just that little bit of bumper-to-bumper compatibility makes a difference. So if you take your examples of the Escalade, against a small car, it's going to ride right over the top of the protective systems that were designed in, and it's going to minimize the effectiveness of the occupant safety that was designed into the car. So unfortunately, when you see a 5-star rated car, it's only that car against a wall. It's not that car against something else. So it's a significant difference. And it also is, if your whole family went in and looked at the car, it's not equally safe for everybody in your family. And so these are the other things that we still need to try to resolve to make things better. But hey, maybe another episode in part 2, we can talk about some more challenges. So.
That actually would be very interesting, because I just had tons more questions pop into my head. And clearly you just made my next car purchase even more complicated. So, Chris, thank you so much. Again, as I mentioned just a second ago, super interesting. Thank you for the statistics, for your perspective, and certainly how you see how mobility is going to be reimagined. Not only where it's going, but also what we should be doing and what we could be doing to reduce these 40,000+ fatalities in the U.S. alone that are clearly, I agree with you, too much. Thank you so much, Chris.